Hello everybody. I have the luxury of telling a bit of history here, a brief history of NSO. It was a bit challenging, but you're sort of getting old and time passes. I had to use some TILF colleagues here to realize, was it 2009 or 2010 we started? But I will tell you the story from 2009 in a while. And Viktor?
Hey.
Will.
Yeah, as I told you about the principles and the design space.
So the purpose of my first talk here, around 20 minutes, is twofold. I mean, products don't come out of nothing. There is a bit of reasoning, there's a bit of motivation. You might look at NSO today and think it's stupid some places. I will try to explain why we made it in a certain way. There is actually reasons for it. Also, what I see right now is that every 10 years, technology seems to repeat itself. So some things we were careful on 10 years ago seems to pop up these days as a new invention. Then Viktor will continue with that. So actually it's a typo here. It wasn't 2010, it was 2009. Spring 2009. Sort of the father of TILF, Håkan Milroth, with his very smart analytical brain, said, there's a galaxy out there, the galaxy needs a new sun called NCS. So the market needs NCS, we can change the market in some way. So me and I have some TILF engineers in here in the room, like Johan, Martin, Kalle, Klack, got a bunch of them, but we started thinking about that guy called NCS. So it had a name at least, but it needs to be something. To automate network. And already 10 years ago, there was a really crowded space. So if you look at network automation 2009, there were basically three categories of product that tried to do network automation at that time. There was a category called Service Activators. They were used by service providers, primarily service providers doing VPN provisioning. Imagine, 10 years ago, they haven't really solved the problem still. 10 years ago, we used Service Activators for that purpose. NCCM tools, network config and change management tools, they were used primarily by large enterprises to keep the device config okay. So they were built for different purposes. Service activators, provision services, NCCMs, make sure I know the config of my devices. And of course, at that time, there were IT config management tools as well. So, I mean, starting to build a new product, you can't start from blind. You need to realize, what do the other products do? How do they do it? What do they do well? What they don't do well? And we need to build something equally good, but that's not good enough. I mean, you had Oracle, HP. We need to be better than that. So equally good, but better. And then you need to look at, how do they do things? There are bad things, there are good things. When you want to Google this night while you're dancing, it's easy to Google some of the product names to see what they actually did. In the service activator space, the most well-known product was maybe HP Service Activator. Me and Viktor actually had a history working with HP, so I could interview a couple of customers that used HP Service Activator to get some feedback on maybe how not to do it. The NCCM tool was really crowded. If you Google these names, more or less none of them exist, but they exist in new shapes. So for example, Opsware is a very well-known NCCM tool at that time that was acquired by HP, becoming HP Network Automation. Cisco actually renamed it, called it Cisco Compliance Manager to do compliance reporting. So lots of them were acquired. And there was no Ansible at that time, it was Chef and Puppet. So looking at these tools, what can we learn before we start actually coding NSO? Or I would probably say NCS. Martin told me, no, it was Urban, I think, told me the history of the name. NCS first stood for Netconf, Netconf Studio Professional or something. Then it meant Netconf Configuration Server initially, and then SDN came, so we needed to be hyped, so it suddenly meant Network Control System. Okay, this service activators, that's sort of spot on. You service providers here, that's what was in service providers at that time, typically Oracle or HP. What were they? As a technical piece of software, how did they work? They were workflow engines, literally workflow engines with adapters. and the designer UI to design the workflow, and operations UI to watch the progress of the workflow. That's how Oracle did it, that's how HP did it, that's how Subex did it, that's how ConfD did it, to talk to the network and provision the services. So it's a step of action. So a service in those tools is a step of actions. That's sort of the service model. And they looked at how do we do it manually, let's repeat that but in a workflow engine. And it's not a bug, it's a feature. They didn't care about device configs at all. They depended on the inventories, heavily dependent on the inventories. The good things they did, they were good at visualization, good at showing sort of what's the sort of visual step of flows when I create my VPN. At runtime, what are the steps? So good visualization. Maybe if you run a reactive FASTMAP loop in NSO, maybe it's not as good at visualizing steps. So that's a good thing with these workflow engines. However, I talked to some customers, primarily for HD Service Activator. If I have a workflow engine touching the devices, note well, I'm not talking about workflow engines for business process automation, that's another thing. I think you're confusing. We can have a discussion over beer. We're confusing network service automation with business process automation. We're blurring border and we're using the wrong tools in the wrong place. Don't use NSO for new hire onboarding, but maybe don't use workflows for touching your network. Simplify. The challenges they had, HP Professional Services, they loved the tool because they stayed for years at every service provider because every different provisioning scenario needed a new workflow. I want to add a branch, new workflow. I want to change point of service, new workflow. I want to decommission service, new workflow. I want to change VLAN, new workflow. So it's an endless creation of workflows to have full lifecycle support. Meaning very huge integration costs, dependencies to inventories, huge integration costs. Kramer and the workflow engine, good luck. Also, they had a big problem with transactionality. So network engineers hated it because they know Saturday, Sunday, I need to fix the network because the workflow engine touched the network. So lots of manual fallouts, lot of half-baked configs in the network. Again, I'm not saying that workflows are bad, I'm saying it's maybe a bad thing to have that workflow engine touch the network. It's a totally different thing for business process automation, we'll turn to that. And it also looks easy initially. You might be scared sometimes, but then say, oh, I need to program, oh, I need to start Emacs. Drag and drop editor, I love it. But the simplicity might hit you at the end for total operational cost. So don't get tricked by, it might look easy at the beginning. NCCMs, they were big at this time, Observer, HP Network Automation, Voyants, etc. They had a different perspective on the world. They didn't care about services, they cared about devices and device configs. And the way they worked is that whenever a network engineer touches the devices directly, there's a config change trap, they pick up the trap, they grab the config, store it. Then they're very good at doing diffing, so they sort of diff the desired config with the existing config. They give it sort of a visual feedback to the network engineer, but then the network engineer changes the devices directly. So basically, they use very expensive backup tools. Very little automation, to be honest. What they were desperately needed was for another automation piece, namely compliance reporting. I think mostly in the US, compliance reporting, like for SOX and PCI, is really painful, you need to automate it. So they're very good at compliance reporting. Because they knew the configure devices can match that against the desired. So looking at these guys, realizing that they weren't actually used for automation, so probably we can't learn that much from these guys. Another thing is that they didn't understand services, they didn't understand device config. So we didn't consider this as an important sort of architectural piece to start building NCS or NSO. But there are a couple of features inside and I will return to. Then if you look at the ITCM tools, well today you would say Ansible, at that time Chef Puppet. They still do a very good job in automating your server part. But they have a totally different perspective. They don't read-write things, they do pull-push. It's more of a long-lived desire state. I want my Apache server to run this way for weeks, for months. That's very different from fine-grained service provisioning tool. So looking at these, since they didn't actually have support for read-write updates, you don't have an API towards the state, and I know a lot of people here are looking at Ansible to do direct network config. Maybe if you have very simple, extremely static backbone network, it's a day zero and then you go home. But if you have changes, it's kind of a scary way to go. And remember, there's no API towards the state. You throw the config to the network and then you go home. There's no state, no API. So really not the good thing for networking, perfect for IT. So that was the background study. Then we started on the whiteboard, the colleagues in the room here. First of all, we need to learn a bit from the NCCM tools. We need to have device state. Service Activators did not. So we need to have the device manager. And we need to model the devices, we need to have the state of the devices. And at that time, kind of a no-brainer since we were at TLF and Martin Werkner worked on IETF. To use Yang there was a fairly obvious move, or even really obvious. A painful thing around the Service Activators was the adapters. So if you bought a Service Activator, you bought a new device, you had to wait 3 to 4 months for new adapters. We need to change something in the business around adapting to the network. And I think as a technical startup, one of the most important things is that TLF invested heavily in IETF. So rather than building a product, which we did for that problem, but we also wanted to change the world in having IETF bringing that ConfD. That was really questioned by that time. I remember a meeting I had with a large service provider. He laughed at us and said, well, thinking that NetConfD will be supported by equipment vendors is like mice visiting there was no cats. So that was sort of the irony at that time. But you can see today it's actually happened. We have the hero Martin in the room here. The other thing, we have another hero, Johan Bevenger on the CLI engine. Competitors needed several months to do a new CLI engine. I remember Johan Bevenger going to a customer, running his CLI engine on the projector and having it up and running after a couple of hours. That sort of a product perspective really changed the adapter pain, because that was also a big pain for service activators talking to CLI devices. And NCCMs didn't do write good, they did not do fine-grained good. So we realized we need to have fine-grained NADs, fine-grained device models, and we need to focus on the write problem, not just the read problem. That was sort of what we learned from the NCCMs. What we did learn from the service activators is that we need to represent the services. And the very crazy idea at that time was to use, for you it's a no-brainer, you use Yang for service models. 10 years ago, weird, really, really weird. Yang was about to become IETF for devices. No one had thought of it for services, because that was UML models or workflows. So can we really use Yang as a service modeling language? It was questioned also by us in the team, but I think we did a good move actually. And today you can see IETF having a taxonomy that some Yang models are service models, and I had heard previous speakers sort of screaming for those. So if you go back to the Galaxy picture, at that time, 10 years ago, you either had service activators doing services or you had NCCMs doing devices. Weird enough, there was no tool in the market that did both. So one of the first critical decisions we said that we need a device manager and a service manager. For you, a no-brainer. But at that time it didn't exist, because you had inventories, you had NCCMs, and you had the service activator, and had to put all those three together, maybe from different vendors. So bringing those two worlds together was really important. Another thing, talking about engineers hating service activators because of manual fallouts, broken config, is that we needed a different transactional model. Service activators typically had 3 transactions. There was one transaction towards the database, the second half-baked transaction towards the devices, and then sort of a third transaction inside them. And these were always inconsistent. So that's why the network and the service activators was always inconsistent. So we extended the transactionality from the services through the device config through the network as one single transaction. All the other product has that as 3 individual transactions, of course inconsistent, all of them. So that transactional model was a big differentiator on the market at the time. And we had the luxury of, we didn't start on an empty whiteboard. We had a beautiful product called ConfD, which Sal loves to talk to us about. That's great technology. I can't go into details here, but lots of building blocks for building NCS at that time we could pick directly from ConfD. So that's really a pearl we could reuse. But going to the $10 million question, so we have service models in Yang, surprise, Yang for that purpose. We have device models in Yang, but how to translate that piece? There we had a couple of weeks of thinking and fighting and sometimes screaming. If I have a service model for VPN, I have some device models for devices, how to transform that? Well, you could go sort of the bare bones API, sort of SNMP managers at that time was mostly based on stuff. So you would have for every leaf, you would have a set leaf, for every list, you would have a modify leaf. That would be quite a lot of programming in sort of a stub API-based approach there. So that was sort of outruled. Another thing that I probably made my case clear is I actually competed, I know Rolf very well, we were colleagues at HP, and he was the boss of HP fulfillment business. And his product was workflow engines, and this was 2009. 7 years later, he actually gave up on workflows. It took him 7 years after we launched NCS. So for us, we realized we can't have an endless work of defining workflows there. So, mostly due to Klakke, he was not here today, I would say, FASTMAP was born. So not a step-by-step workflow engine, but look at it as a data model transformation. And you programmers in the room, not all programmers realize when they do the create method, they think of it as sort of an imperative step-by-step thing. It's not. It's a model transformation. So it's a model transformation from the service model to the device model. It's pure functional. You shouldn't write to disk like. So it's a transformation of one data model to another model, like XSLT transforms. So with that, having that, you define just a simple create case as a transform, not as a sequence of action, and at runtime it renders any kind of update scenario and delete scenario. I intended to explain FASTMAP, but I skipped it here because Viktor has an important story to tell as well. Maybe the most important thing that we forget, when you on Monday morning go, how to program the create method, maybe you forget the benefit. You like buy one ice cream, but you get 9 ice creams for free, which you sometimes don't realize because you're so used to that. So based on that single create data model transform, you get any kind of modification, modifying quas, changing VLAN, changing interface parameters. There's no sort of explicit stub callbacks, there's no explicit workflow definitions. Keeping track of dependencies, changing a VLAN on a service, which kind of impact does that have on the device is very complex to do by programming, but FASTMAP gives it for you. Redeploying a marvelous method. You can modify things, you can change the topology, just throw redeploy to service and it recalculates all the changes. Doing that in APIs or workflows, I think you would never be done. Cleaning up the good old friend checksync. All of those you get for free from FASTMAP. So remember that next time you program create, I think it's a bit tedious. FASTMAP, I think that's Klakke's patent, maybe, I don't remember, Joe almost at 2010 maybe, I think so, something, coined. Sometimes we call it state convergence. No one heard of intent-driven at that time, so that's sort of the spoiler warning for Viktor here. What is intent-driven orchestration really?
Right, so Stefan's talked about NSO, how NSO came to be. And I want to talk a little bit about the design space, because I have a lot of conversation around NSO, how it works, and perhaps more important in this context, people are telling me how it should work. So I want to talk a little bit about the taxonomy, what the options are, and the idea here is it might be a good background when we try to talk about what NSO should be and what orchestration should be. So first of all, we have two main threads when it comes to automation. The first one is intent-based interfaces. So the intent-based interface is one where you use the interface by declaring an intent. So there are some principles for these types of interfaces. One is that write your intent is enough. You are transferring responsibility to the system you're configuring. You give your intent, you say, I want this interface to be configured. I want this VPN to be up. And the system takes over responsibility for fulfilling that intent. And it is responsible for striving to execute an intent. It is idempotent, that is, you only have to write it once, and no matter how many times you write it, it still means the same thing. It doesn't matter what the current state is. What you're doing with your intent is you're expressing a wish for something to happen. And you might want the interface to be up, but for instance, it might not be possible. There might not currently be a cable in that port or something like that. But if you can give your interface, your intent, it doesn't matter what your current state is. And the system never modifies its intent. It's assumed that the system has some internal state that controls how it's executing intent. But the intent is something that's come from a system above you, and that's what the system is always executing on. So intent is sort of configuration done right. The other main option we have, besides intent, is command-driven interfaces. Here, rather than writing configuration or intent, we're giving explicit commands saying, please do this, please do that. You give commands to move between states. And because commands move between states, you need to know and understand what the current state is like. And the current command depends on that state. So the state always has to be exposed to the user. And to achieve an effect, you need a sequence of commands given at the right time, in the right way to achieve your effect. And the automation that becomes sort of workflows, runbooks. Now, these are the two main principles we have. In practice, pretty much any automation or orchestration problem will be solved by a mix of these two, because there are some commands that are very natural, such as reset, reload, reboot. And pretty much every system has some aspect of configuration. So you want to run a number of commands, and you want to declare intent toward the system. And there are a few different ways of doing this. So when we talk about intent-based networking, this is what we're talking about, right? A way of declaring your intent and having the system execute on that. Now, I'm talking most about automation. There is another aspect of this, which is reporting, performance management, fault management, or an entire assurance stack. And that, of course, works on similar principles, but I ignore that for now. Also worth mentioning that this idea of intent is not limited to a single place in the network. You want your router to be intent-based. You want to have a very good intent-based API towards your device. But you also want an intent-based interface towards your orchestrator, towards your SDN controller, towards your element manager. And having good intent-based interfaces, it allows things like delayed service restriction. Because that means that you get the same benefits at every level and can keep reusing the interfaces. Command-driven interfaces are harder because that complexity multiplies with every level of interaction you have. So let's start talking about automation. So you start out with manual operation. I created a small taxonomy here about sort of the features you want in your automation and what you get from various ways of automating. So what is it you want to do? Well, you want to have configuration. You want a way of deciding which configuration should go onto your network. You want rollback. If something goes wrong, you want to go back to the original state. You want compliance check. You want to verify that the current configuration in the network is compliant with your desired configuration. You need a way to create services. That is, you need a way to create instances of a service. You need a way of modifying and deleting services. You need a way of handling brownfield. That is, if there is already configuration on my device, how do I make sure that my new configuration works together with that, and that I understand the brownfield situation. You need cross-device coherence, that is, if I have a VPN tunnel, how do I make sure that both ends use the same credentials? How do I make sure that the network is configured in a consistent way? How do I handle human approval? How do I get information on the progress of my automation? So we all start from sort of a manual baseline, and there pretty much everything is manual. And this is a situation we're trying to move away from into a more automated situation. So the first, perhaps most obvious step is to add a little bit of scripting. So scripting allows you to use explicit programming for at least some of the features, but a lot of this still remains manual, and you still need to explicitly program sort of every aspect of your automation. Now, that's not to say that all scripting is the same. You still have a lot of tools to ease your work. You still have a lot of libraries and helpers to make a task easier. And there is a lot going on in this space these days. There is Ansible, Salt, Nornir, Napalm, and all these pretty nice, in many cases, scripting tools. But what they have in common is that they leave you with doing the work. And as Stefan was saying, you know, when moving into NSO, we're trying to sort of build something that could do more, that could remove part of the burden. So the next step is to add a service designer. And by service designer here, I mean something like a tool for creating workflows or scripts or templates. It's a design tool to make part of your experience better. And having a service designer, there are a few interesting ones. You start getting some things automatic. You start getting service creation automatic. And at least in theory, I have never seen this, but it would be possible to get modification and deletion as well by the designer. But you still need to explicitly program some parts around rollback and compliance and all that. And the next step in this sort of evolution towards automation might be to add a workflow on top of that. So you have your device configuration, you have your designer, and here, and this is perhaps a context where you most often see these service designers around designing the workflow, a graphical interface for building up the steps. And what you're essentially doing here is you're performing your scripting in multiple steps. This gives you a few benefits, right? You start getting human approval and progress information. It becomes slightly easier to integrate this in your overall system. And the classical service activators did a lot like this, right? If you implement scripting, service design, workflow in a very good way, you get sort of a good service activator. But as we were talking about, NSO took a slightly different route. In the NSO case, we start doing transactions instead of scripting, or rather scripting on top of a transaction. So what happens once the transactions? Well, you get automatic rollback, you get automatic cross-device coherence, but you still have to do everything else by regular programming. So adding a transaction layer, that's sort of the first step towards something that looks like NSO. And a transaction in this case is not that much, right? A transaction is a mutual snapshot that you can commit to the network. It allows you to read and write from a session, a transaction, that you can then commit at the end. And the transaction has to support all or nothing, that is, either it's completely committed or not committed at all. And it guarantees consistency in your network and your system. And you can imagine a transaction system alone. In the NSO case, even without the service manager, if you look at just NSO without services, you have transactions plus a database. And with a database, you get slightly more, right? Once you store your information in a database, you have subscription of changes, you have analysis of the configuration, you can start getting compliance checks automatically as well. But in theory, right, if you look at NSO, you wouldn't have to have a database. You could just do a sync from on every transaction, modify it and commit it back to a network without having a database, if all you wanted was a transaction. So this is what you have in NSO without services. If you're not using FASTMAP, you can still create services manually. And this is something that's very rarely done, but there are some cases where it can be done. There are some cases where it's very helpful to do things without services. But of course, we have these services. And now we're talking about transactions plus a database plus a FASTMAP view. And of course, you get more and more stuff, right? You start getting service modification, service deletion. You get a little bit of brownfield because you can start being able to do integrity checks. You can do various forms of sync checks towards the network on your service instance. You can do a little bit of no override and partial syncs and stuff like that. And so this starts allowing you to do more and more stuff through automatic means. But you still explicitly need to create a service. And you still have some stuff that NSO does not do, right? You do not do human approval. You do not do progress information in any way except the fact that we have the result of our transaction. So this is sort of what we start getting or build up to NSO. And we have a few requirements of the database. And you need a very competent database. I mean, Stefan talked about stuff that he got for free from ConfD. One of those was a very good database for this purpose. It supported Yang as a data model, that had the right tree format and could validate according to the Yang standards. We have transactions with these writable snapshots, and the tonicity, we need some global consistency. And this is where the device managers start coming in, and support for subscribers and data handlers. And what FASTMAP crucially depends on is the ability to calculate the diff for each of the transactions. To be able to keep track of not just right now, but also storing which changes belong to a certain transaction. So this is sort of the story up to NSO, and then things start getting advanced. And there's a lab going on right now, Reactive FASTMAP. I'm not going to cover this too deeply, but I'm going to talk a little bit about this design space, because what happens once you go beyond what you can do in a single transaction? What if you can't do this in a single change? I sometimes talk about this as reversing around corners, right? You can't always take the fastest path, because that is what FASTMAP does, what this convergence tends to do. It wants to take the minimal diff between your desired state and your current state. But sometimes that is impossible. For instance, in this example, we have a virtual machine. It first needs to be started before it can be configured. And then you need to start dividing into multiple reactions, as we call them. And then, there are a few reasons for this. It can be that we need a side effect, an actual side effect. It might be that an underlying system that is not intent-based, that really does require sequence operations. And then we use the Reactive FASTMAP to do that. So, Reactive FASTMAP, that is putting the dependencies into service code on the operational state. And then there was a new primitive added to run FASTMAP over and over again, and kickers or subscribers to run Reactive redeploy when the operational state changes. And this allows us to drive the service progress when changes happen. So, you know, same FASTMAP, same database, a new usage pattern that we're adding more and more support for. And perhaps the coolest thing that we've done recently is what is called Nano Services. There's a tutorial tomorrow morning, 9 to 11, and there is a lab as well. So I really recommend looking at that. It allows you to declare a plan in your YAG model and then execute your service code according to what happens in that plan. This is one example of a plan here with components going on. So it moves your declarative YAG model based approach into the reactive FASTMAP. And the huge benefit of this is it allows a much more efficient life cycle. And when I say life cycle here, I mean in particular delete, because delete in general is assumed for FASTMAP to be a single step. But just as you might need multiple steps to create a complex service, you might need multiple steps to remove it. You might, for instance, want to release a license before you release a virtual machine, or something like that. So these are all the cool stuff. We have an NSO. So do you want to start this?
Mm-hmm. How are we on timing, Niklas?
Fine.
Okay, we have 10 minutes.
Okay. So let's zoom out a bit. So NSO lives in an environment at every customer, and there is no chance NSO will solve world hunger. There's a lot of surrounding pieces here. I will not talk about assurance, my other favorite topic. You can walk up there to me standing in the Netrounds table to talk about assurance. I'm skipping assurance right now, which is really important. If you provision things, we can test if they work. But let's stick with, there we are. Let's stick with sort of configuration, activation, fulfillment, whatever we call it. Let's look at two scenarios. So how does NSO fit into the bigger picture in this case, probably more of an enterprise environment or more in an application hosting environment, where you're not selling network connectivity, but you're maybe selling hosted applications like digital cloud, where I want a web server, I want the load balancers, please spin it up for me, and that tedious, boring networking I don't want to see. So the primary sort of top-level object is an IT application. The stack might then look like this. So then you use NSO for the networking piece. But since your prime purpose as an enterprise in this case is actually IT applications, and no way I would push NSO if I would need to run web servers, databases, I would use Ansible or Chef or Puppet or whatever. So I would use something like that on top of NSO. Here would leave sort of the top services, if you so like, dispatch to NSO for networking and do the IT piece directly. A little bit of trick here, which we can discuss in the evening, is it's still kind of stateless. So we're getting back to that painful CMDB or inventory thing. Let's stop the discussion here because that's a bit of pain. But so we just recall that. But then to the hot potato, and of course there is something like a workflow north here. In this case, probably north of Ansible, probably not north of NSO. What are workflows good for? Workflows, basically, if you, and some experts up there from BPA or Potential can correct me, but if you try to summarize what are workflow engines really, and maybe the best summary, at least in my mind, is they are very good at routing tasks between roles. So it's me routing a task to Sal routing a task to Johan routing a task back, and then done. So it's routing tasks between roles within an organization, going back to Viktor's point about human approvals. That's what they do. So it's business process automation, not network service automation. Very important distinction. So it has to deal with humans, it has to deal with routing tasks between roles and manual steps. And think thoroughly on this interface here. So let the workflow engines do what they're good at, let Ansible do what Ansible is good at, and be careful when you put the border here. I will talk a little bit more on that side. This is a perfect architecture. So you need to understand what we're saying here. NSO is good at certain things. IT config tools are good at certain things. Workflow engines are good at certain things, but don't confuse them. I see a lot of confusion today, especially when I go over here. If you're a network-centric environment, and we have seen examples like Orange this morning, where you have iTential north of NSO, perfect. Two different things, two different domains. Business process automation, one thing. Network service automation, totally different thing. But again, be careful where you put that border. I've seen some examples, if you push that border too far down, I see some NSO customers more or less just using the network element drivers. And then they put the workflow engine on top of the device manager. Don't do that. Tomorrow there's free beer. If you do that, there's no free beer. Understand what NSO gives you from 100% automation of network service automation, no hands, fully automated, transactions, FASTMAP, and then put the workflow engine on top of that. Really easy integration, no kind of trying to do rollbacks up here. Another thing I've seen here is making NSO working like NCCMs, meaning some people use NSO for sort of getting the config from the devices, doing a diff inside NSO and seeing the diff, and then maybe pushing the whole blob again down there. That's making NSO into an NCCM. So no beer for you guys tomorrow either. And another thing to bear in mind here is that with the things that Viktor talked about is that with Nano Services, NSO actually is jumping up with it. And NSO, use NSO for the things that are black box, totally automated. And if you sort of come to cases where you have A, B, and C, and you think that FASTMAP, it's hard to sequence A, B, and C. Maybe I escape and use my Camunda north of NSO to do A, B, and C. You could do it to one-line Python, but maybe you pick a workflow engine to do A, B, and C. Look at Nano Services, utilize Nano Services, because the good thing with Nano Services is that you get FASTMAP, you get so more of a state machine approach, but black box fully automation, native. And then again, use workflows north of that to drive the sort of the business. So look at Nano Services, realize that it makes the interface from iTential, from BPA, from Camunda better, easier to do the business up here, but you utilize the things with NSO. And don't sort of miss the point of Nano Services for doing fully automated things. On visibility, one thing we did really lack early on NSO, it was visibility, which workflow engines are really good at visualizing the whole process. Where are we in the flow and the additional plans? I hear some people are not aware of the plans in NSO. Comes a little bit with Nano Services, but that helps you. Still maybe not the blinking UI, but it shows the progress. Also makes the interface up to the workflow engines much easier. So be careful when you design this guy. What's the interface here? Use workflows for business process automation. Use NSO for network service automation. Be careful of the border in between them. Another thing to think about, what are these guys? What are the workflow engines? You have very good examples up here. You have iTential, it's one example. You have BPA, it's another example. You can talk to my colleague Scott from the Ductus using Camunda as another piece. I don't, honestly, those are different products. Pick the best one. Also remember that most enterprises, they have their service now. Most telcos have their remedy. Those are also workflow engines. So, because the more layers you put in the solution stack, the more complexity you get, the more inconsistencies you get. So look, what do I have my service now? Do I have my remedy? Maybe you should start there then. Put that on top of NSO. So be smart. Use the tools what they're good at. So what is the message from me and Viktor here? The first message is that principles matter. I mean, we did FASTMAP for a big reason. We did move away from command-oriented interfaces. We moved to state convergence in FASTMAP for a big reason. And they are really important. You get lots of things for free. If you start sort of demoting that and putting something else to manage the sort of the state of the service, you lose a lot. So don't pollute FASTMAP with sort of scripts hooking in within FASTMAP, you lose a lot. So learn the principles, understand the principles and the value of them. And a bit of history repeats itself. As I said, Rolf Eberhardt gave up on workflows, remember, touching the network. I see some people pushing workflows closer and closer to the network. That's going back 10 years in time. Earth is flat. Use workflows what they are good at. Business process automation. Because they're really good at that. Visualizing, showing, routing tasks between individuals and roles. Viktor?
Yes, right. And the final two things, right, is that it's very important when we talk about NSO and the changes we're making to NSO and what we want to see in the future, that we do things that work with the design philosophy we're using. And that we think about how a change fits into the overall architecture. Often in discussions, it's very easy to start talking about things that aren't really suitable for NSO or architecture we're trying to go for. So it's very important, as we said, to understand the principles and how they best apply. And finally, NSO works today, right? It's a mature product. It's been 10 years, and we're seeing a lot of really cool improvements. We saw from SoftBank how they've been going from NCS over to NSO, and up to 4, 5, and then probably up to 5 now. And it really does work. It's really nice to see all the cool stuff that's happening. Yeah. That's it.
Yeah.
Cisco, the bridge to possible.